Scientific notation. Someone can ask for what we need the scientific notation. You have to realize that in mathematics, physics, or electronics, or any other subject which is related to mathematics, we have to deal with very long numbers. Okay, I don't say big numbers or small numbers, I'm talking about the long numbers, because small number can be very long and big number can be also very long. Imagine that we wouldn't have engineering notation or scientific notation. We would have in our notebooks the numbers like 100,000s, 100 millions, billions, and so on, so on. And let's say that's why we need scientific notation. We have to make the long numbers short. Now, before I'm going to start explaining this topic, let me just write the formulas for you which we are going to use. Remember, anytime exponent will go up, number has to go down. Okay, and anytime exponent will decrease, number will increase. Okay, also you're supposed to remember that 10 to 0 is equal 1. You have to remember these three very important rules. Now, also, if we are going to talk about scientific notation, you're supposed to keep in mind that the number on the left side of decimal point, okay, supposed to be always between 1 and 9. Cannot be less than 1 and cannot be greater than 9. Okay? Now, what I mean, let's take a look at this example. Let's say I have 578. Okay? I want to convert this number to scientific notation. What am I supposed to do? First, you have to keep in mind that anytime there is no decimal point written, okay, next to the number, there is always decimal point at the end of the number. Also, anytime we are going to have scientific notation, we are going to use powers of 10. Okay? Anytime we do not have multiplier, we have to write 10 to 0. Okay? Why? 10 to 0 is equal 1. Okay? 1 times 578 is just 578. So this multiplier at this moment is not changing my number. We said that anytime we have scientific notation, the number on the left side of decimal point is supposed to be between 1 and 9. Now I have number on the left side of the decimal point 578. Okay? So this is for sure not yet scientific notation. What I have to do? I have to move my decimal point, okay, after 5. 5 is the number which is between these two numbers, okay? So I move my decimal point twice to left. My number got smaller because before I had 578, this time I have 5.78. According to the rule, anytime number goes down, exponent has to go up. Okay? So if I move my decimal point twice to left, right? My exponent has to go up twice. That's why my answer is going to be 5.78 times 10 to the second power. Let's do one more example. Let's say I have 0.00347. Again, first, realize that we do not have multiplier. We have to create one. 10 to 0. 10 to 0 is equal 1. 1 times this number, okay, is not going to change anything. Okay? So, the question is why I'm using it. because this helps me to solve the problem. Now, remember, we're supposed to have the number on the left side of the decimal point between 1 and 9. Okay? Now I have 0. I cannot have 0 if I'm talking about scientific notation on the left side of the decimal point. That's why I'm going to move my decimal point 1, 2, 3. 3 times to the right side. Now, anytime you move the decimal point to the right, your number is going to get bigger. So the number got bigger. Exponent has to get smaller. Okay? So that's why I'm going to have 3.47 times 10 to negative 3. If some of you have difficulties with finding this exponent, let me just remind you about the number line. Okay? This is 0, this is -1, -2, -3, -4, -5, -6. Let's say 1, 2, 3, 4, 5, 6, and so on. Okay? Now, the number got bigger. Exponent, at the beginning we had 0. Exponent has to get smaller. We moved the decimal point 3 times, that's why we went down 3 times. That's why I got -3. And this is the solution to this problem.